In this video, we're going to integrate exponential functions using the substitution method. In the first question, we have integral e to the x plus e to the x dx. So the first thing we're going to do is rewrite this as e to the x plus x dx. Applying the property of exponentials, we can rewrite this as e to the x times e to the x dx. So we split up the exponentials. All right, let's let u be equal to the exponent e to the x. du, the derivative, is e to the x dx. So what we get is integral e to the x times e to the x dx is equal to integral e to the u times e to the x dx. This part is just du, and this part is e to the u. So that's going to be e to the u du, and the derivative of e to the u is just going to be itself, e to the u plus c. Now plug u back in, substitute u back in, you get e to the x plus c. So what we have shown here is that the integral of e to the x plus e to the x dx, all of this is an exponent. The answer is e to the x plus c. All right, let's look at another example. Here we have integral of 3 to the x dx. This is a slightly more difficult example. The first thing we're going to do is rewrite 3 to the x to the base e. That will make it easier to apply the substitution method. So we have integral e to the ln of 3 to the x dx. And the property that we applied is that e to the ln x is equal to x, and ln of e to the x is also x. All right, so what we have is integral e to the ln of 3 to the x dx. We can bring the exponent down in front of the log, so we get integral e to the x log 3 dx. Now let's apply the substitution method. We let u be equal to x log 3 du, the derivative, is log 3 dx. So we have integral e to the x log 3 dx is equal to integral e to the u times dx. Let's solve for dx. So dividing both sides by log 3 and divide by log 3, the log 3 cancels out. We get 1 over log 3 du is equal to dx. All right, so dx is going to be 1 over log 3 times du. 1 over log 3 is a constant. It passes through the integral, and we get 1 over log 3 integral e to the u du. And the derivative of e to the u is itself, it's just e to the u. So we get 1 over log 3 e to the u plus c. Plugging u back in, we get 1 over log 3 e to the u, which is x log 3 plus c. Let's rewrite it in the original form of the question. We get 1 over log 3 to the x plus c. So we apply some exponential laws, exponential rules to help us with the algebra here. So what we have shown is integral 3 to the x dx is equal to 1 over log 3 times 3 to the x plus c. All right, let's look at another example. Here we have antiderivative of e to the root x divided by root x. Notice that root x is just equal to root x is the same thing as x to the 1/2. All right, let me rewrite that. Root x is equal to x to the 1/2. Okay, so we're going to apply the substitution method. Let t be equal to root x, which is x to the 1/2, dt is equal to 1/2 x to the negative 1/2 dx. So we get dt is 1 over 2 root x dx. And let's solve for dx over root x, and we do that by multiplying both sides by 2, so we get 2 dt is equal to 1 over root x dx. Let's rewrite the integral as e to the root x times 1 over root x dx. We've shown that this part, e to the root x, that's going to be e to the t, and 1 over root x dx, that is 2 dt. So this integral will be integral e to the t times 2 dt. Now it's in terms of t, and it's easy to integrate. So 2 is a constant, passes through the integral. We get 2 integral e to the t dt, and antiderivative of e to the t is itself, so we get 2 e to the t plus c. Plug t back in, t is equal to root x, so we get 2 e to the root x plus c. So what we have shown is integral e to the root x divided by root x is equal to 2 e to the root x plus c. Okay, one more question. So here we have integral e to the x minus e to the minus x divided by e to the x plus e to the minus x. When we first look at this, it's hard to see how to choose u, but there's only so many possibilities. Either you're going to let u be equal to the numerator or the denominator. So we can see that if we let u be equal to the denominator, e to the x plus e to the minus x, then its derivative gives us the numerator. So du is equal to e to the x, and differentiating e to the minus x using the chain rule, we get minus e to the minus x all times dx. So let's rewrite the integral as 1 over e to the x plus e to the minus x times e to the x minus e to the minus x, all in brackets, times dx. So what we have is 1 over u, that's the denominator is u, and this part here is going to be du. And this part, of course, is 1 over u. So you get 1 over u du. Antiderivative of 1 over u is going to be log of u. That's log of u plus c. Now substitute u back in, and we get log of e to the x plus e to the minus x plus c. Now, we don't really need the absolute value because e to the x is always a positive number, and so is e to the minus x. So you're adding two positive things. It's always going to be it's always going to be positive. So e to the x plus e to the minus x is always larger than 0. So we'll drop the absolute value, and we get ln of e to the x plus e to the minus x plus c. This is the answer for solving this integral. All right, thanks. I need to make a correction. On the last line, we have integral e to root x over root x. I forgot to put dx. You always need dx whenever you have an integral. So if you have an integral, you got to have a dx. All right, thanks.